A company gives prospective workers a 6-question multiple choice test. Each question has 5 possible answers, so that there's a 20% chance of answering each question correctly, just by guessing. Find the probability of the following results by chance. So this is similar to an earlier question, but it's not a bad idea to see similar questions. We want to, first I recognize that this is binomial. And the reason I recognize this is binomial is because we have 6 questions. Each of them are independent of the other. There's a 20% chance that I get the first question right, and it doesn't depend on if I'm going to get the second or the third question right. It's always a 20% chance. So we've, and I'm just counting the number of successes here. I'm not trying to arrange them or anything like that. So I'll count a success as getting a question correct. Alright, so n, p, and x, those are the things I need to figure out numbers for. N is 6, there's 6 trials. P is the probability of 20%, or 0.2. If you want to write 1/5 there, you could do that as well. And we're trying to find the probability of getting exactly 2 correct answers. So x is 2, this would be binomial. PDF 6.22. Which gives us a probability of 0.24576. That looks like an exact probability, so I'm just writing the whole thing down. The probability that you get no correct answers here. Alright, so this is almost the same question. We get n equals 6 and p equals 0.2, but now the number of correct answers is 0, so this would be binomial. PDF 6.20. So I'm going to just take my answer on the calculator, hit second enter, and change this 2 to a 0 for 0 successes. We get 0.262144. Alright, part C, the probability we got exactly, or at least 4 correct answers. N is still 6, P is still 0.2. But in this case, we're saying at least a certain number of correct answers. So let me write up here 0, 1, 2, 3, 4, 5, 6. If we want to get at least 4 correct answers, that means we want to be there. And to figure this out, I could figure out the probability of getting exactly 4 and add that to the probability of getting exactly 5, add that to the probability of getting exactly 6. Or what I'm going to do is use my complement rule and figure out the probability of getting less than or equal to 3. And use that as my complement. So the probability that x is greater than or equal to 4 is equal to 1 minus the probability that x is less than or equal to 3. Those are complements. And this less than or equal to 3, that's the thing I can use my binomial CDF on. 6.23. So get 1 minus the binomial CDF of 6.2, was it 3? Yeah, it was 3. 0.1696. 0.01696. Alright, and part D here, the probability we get no more than, oops, I should probably finish writing this. X is greater than or equal to 4. The probability we get no more than 4 correct answers. 0, 1, 2, 3, 4, 5, or 6. No more than 3 means we're talking about this probability right here, and this means we don't need to use a complement, we just want to use the binomial CDF by itself. 6.2, and with the probability, or with a no more than 3 successes. So binomial CDF 6.23, which gives us a probability of 0.98304.